Your Python trading script passes every backtest with 0 errors. But the second you deploy it to a live broker account, the execution breaks completely. The broker server rejects your orders with error code 10030, reporting an invalid order fill type. Your algorithm sits idle, missing trades while market opportunities pass by. In this video, you will learn how to build a dynamic order filling handler in Python that queries your broker server execution rules and prevents fill mode rejections automatically. No bull trading. I have spent 6 years building and running automated trading scripts across Forex, equities, and crypto using Python and MetaTrader 5. One of the most common friction points for aspiring bot builders is the gap between simulated backtesting execution and real broker server plumbing. Most online tutorials teach you to hardcode your order fill type as immediate or cancel. In the backtester, that code executes without issue because the tester engine emulates an ideal execution environment. On a live trading account, hard-coded order modes often fail immediately. Today we are going to fix that execution bug permanently with clean production logic. To understand why live orders get rejected, we first need to look at how order execution modes work inside MetaTrader 5. The first mode is immediate or cancel, commonly written as IOC. When an IOC order is sent, the broker fills as much volume as available at your target price and cancels any remaining unfilled volume. The second mode is fill or kill, or FOK. Under FOK rules, the broker must execute your entire position size and full immediately, or cancel the entire order instantly if full liquidity is unavailable. The third mode is return, or book execution. If an order is partially filled, the remaining volume stays open on the order book as a resting market or limit request. The problem begins when a developer assumes that every broker supports every fill mode on every symbol. Different brokers configure their trade servers differently based on their liquidity providers, execution routing type, and asset class. If your Python script sends an order configured for IOC, but your broker server only accepts return mode for that specific instrument, the trade server immediately rejects the request with code 10030. In live automated trading, an unhandled execution rejection means your position management logic breaks, risk calculations desynchronize, and your strategy fails to enter trades. What makes this issue particularly dangerous is that the MetaTrader 5 strategy tester intentionally obscures it. The strategy tester handles execution in a controlled environment where hard-coded fill modes are frequently bypassed or mapped automatically. Your backtest shows clean equity curves and crisp entry fills. But the moment you connect your script to live liquidity, the trade server enforces strict account rules, and your automated system breaks. To prevent these execution errors, we need to inspect the symbol specifications directly from the active trade server before sending any trade request dictionary. MetaTrader 5 exposes symbol-level execution capabilities through the symbol info function in the Python client library. When you inspect the filling mode attribute on a symbol info object, MetaTrader 5 does not return a simple string. It returns an integer bitmask that represents all supported execution types combined. A bitmask stores multiple true or false flags inside a single numerical value using binary position bits. For example, a value of 1 indicates fill or kill support. A value of 2 indicates immediate or cancel support. A value of 4 indicates return mode support. If a broker symbol supports both fill or kill and immediate or cancel, the trade server combines these bits into an integer value of 3. If you attempt to evaluate these execution modes using standard equality checks like double equals, your code will fail whenever a symbol supports multiple filling options simultaneously. Checking if filling mode equals 2 will fail if the server reports a combined flag value of 3, even though immediate or cancel is fully supported. To evaluate supported fill types correctly, we must use bitwise binary comparisons using the ampersand operator in Python. This ensures our execution module accurately identifies every fill mode allowed by the broker for any given symbol in real time. Now let us construct a robust, reusable Python function that dynamically resolves valid fill modes before an order payload is built. We define a function called getSupportedFillingMode that accepts the trading symbol as its primary input argument. First, the function requests symbol information from the connected MetaTrader 5 terminal and verifies that the returned object is valid. If the symbol object exists, we extract the integer bitmask value stored inside the filling mode attribute. Next, we evaluate the flag variable against official MetaTrader 5 constants, prioritizing fill modes based on execution reliability. We first test if the immediate or cancel bit is present using the bitwise ampersand check against symbol filling IOC. If that bit comparison returns true, the function immediately returns order filling IOC for our trade payload. If IOC is unsupported, the function evaluates the fill or kill flag against symbol filling FOK using the same bitwise operation. If neither flag is explicit, or if the server defaults to book execution, the function falls back safely to order filling return. By passing your target symbol through this dynamic resolution helper, your order submission module dynamically assigns a server-accepted fill mode every single time. Here is the unvarnished reality about automated order execution infrastructure. A trading strategy is only as good as its order routing plumbing. You can spend hundreds of hours optimizing parameter grids and refining signal generation, but an unhandled infrastructure bug will offline your system in production. However, you must understand the trade-off that this dynamic fix introduces. Resolving order rejections dynamically solves execution errors, but it does not remove execution risk. If your dynamic handler falls back to return mode on a liquid symbol, your bot may experience partial fills. A partial fill means your order enters the market with half its intended position size, altering your risk to reward balance and position sizing mathematics. Alternatively, falling back to fill or kill during volatile conditions means your entire trade may be rejected if full volume is unavailable at your price. You eliminate code crashes, but you inherit the structural execution behavior of that specific fill type. True algorithmic reliability means expecting these broker differences and accounting for them in code before deploying real capital. Let us recap the 3 key takeaways from today's postmortem breakdown. First, never hardcode execution parameters like order fill types inside live Python trading scripts. Second, always inspect symbol execution flags directly from the active trade server using bitwise mask operations. Third, ensure your post-trade position tracking logic accounts for partial fills and order cancellations when fallback modes execute. If you want real technical teardowns of trading bot infrastructure without hype or sales pitches, subscribe to the channel. In the next video, we are dissecting slippage calculation errors in tick data backtests and showing why simulated spread modeling lies to you. This video is for educational purposes only and is not financial advice. This video uses an AI-generated voice.